Our solar system is a vast and mysterious place. Among its wonders is Mars, the fourth planet from the Sun. Known as the Red Planet, Mars has captivated humanity for centuries. Its reddish hue, visible even to the naked eye, sets it apart in the night sky. Scientists and dreamers alike have long pondered the secrets hidden beneath its rusty surface. Mars is a planet of stark beauty and contrasts. Towering volcanoes rise above desolate plains. Deep canyons scar its face, hinting at a turbulent past. Evidence suggests that Mars was once a much different place than it is today. Rivers may have flowed and oceans may have existed. Could life have arisen on this distant world? The question of life on Mars is one that has driven countless missions to the Red Planet. Spacecraft have orbited, landed, and roved across its surface, each mission adding a new piece to the puzzle. We have learned much about Mars's geology, its atmosphere, and its history. Yet the question of life remains. The search for life beyond Earth is a profound one. It speaks to our place in the cosmos and the fundamental nature of existence. If we were to find evidence of even microbial life on Mars, it would be a discovery that would change our understanding of the universe forever. In 2020, NASA's Perseverance Rover embarked on a daring mission to Mars. This sophisticated robotic explorer carried the hopes and dreams of scientists around the world. Its destination, Jezero Crater, believed to have once held a vast lake. Jezero Crater was chosen for its potential to harbor signs of past life. If life ever existed on Mars, Jezero Crater would be the ideal place to find it. The rover is equipped with scientific instruments to study Mars in detail. Among its tools are cameras, spectrometers, and drills, all working together to unlock the secrets of the Red Planet. The rover's mission is to search for signs of ancient life, study the planet's geology and climate, and collect samples for future return to Earth. Since its arrival, Perseverance has been tirelessly exploring, sending back stunning images and valuable data. The rover's travels have taken it across ancient lake beds and up the slopes of towering deltas. Along the way, it has made a discovery that has excited the scientific community. Perseverance has uncovered a rock sample with clues about Mars's past. This rock, nicknamed Cheyava Falls, has become a focal point of the mission. The rock's unique characteristics could hold the key to unraveling the mystery of life on Mars. The rock sample known as Cheyava Falls is no ordinary Martian rock. Its distinctive arrowhead shape and unusual composition set it apart from the surrounding terrain. Scientists believe that this rock formed billions of years ago when Mars was a much wetter and potentially habitable planet. The most striking feature of Cheyava Falls is the presence of two vertical veins of calcium sulfate. These veins, running like white stripes through the reddish rock, are evidence of past water activity. Scientists believe that these veins formed when water, rich in dissolved minerals, flowed through cracks in the rock and deposited the calcium sulfate over time. The presence of calcium sulfate veins is significant because it suggests that liquid water once existed on Mars for an extended period. Liquid water is essential for life as we know it. Its presence on ancient Mars raises the possibility that life may have also existed there. But the calcium sulfate veins are not the only intriguing feature of Cheyava Falls. The rock also exhibits a central band marked by distinct leopard spots. These spots, appearing as darker, irregular patches against the lighter rock, have puzzled scientists. Their origin and significance are still being investigated, but they could hold further clues about Mars's past. Section 4. Leopard spots and ancient clues. The leopard spots on Cheyava Falls have sparked intense curiosity among scientists. These spots, with their distinctive patterns and coloration, are unlike anything seen before on Mars. Their origin and composition are still being debated, but several theories have emerged. One possibility is that the leopard spots are the result of chemical reactions that occurred within the rock long ago. These reactions could have been triggered by the interaction of water, minerals, and perhaps even organic matter. The spots could represent areas where the rock's composition was altered by these ancient processes. Another theory suggests that the leopard spots may be evidence of microbial life. On Earth, certain types of microbes are known to create distinctive patterns and textures in rocks. Could the leopard spots be the fossilized remnants of similar Martian microbes? The possibility that the leopard spots could be linked to ancient life is an exciting one, but scientists are cautious. Much more research is needed to determine the true nature of these enigmatic features. However, Their presence adds to the growing body of evidence suggesting that Mars may have once been a much more hospitable place than it is today. Section 5. Organic compounds, hints of life. In addition to the calcium sulfate veins and leopard spots, Cheyava Falls has yielded another tantalizing clue: organic compounds. Organic compounds are the building blocks of life as we know it. Their presence in Martian rocks has long been sought after by scientists searching for signs of past or present life. The organic compounds were detected by Sherlock, one of the instruments on board the Perseverance Rover. Sherlock uses a technique called Raman spectroscopy to identify the chemical composition of materials. When Sherlock analyzed the Cheyava Falls sample, it detected a signal consistent with the presence of organic molecules. The detection of organic compounds in Cheyava Falls is not definitive proof of life, but it is a significant finding nonetheless. Organic compounds can be created by both biological and non-biological processes. However, their presence in a rock that also shows evidence of past water activity and potentially habitable conditions is highly suggestive. To further investigate the organic compounds in Cheyava Falls, scientists will need to analyze the samples in laboratories on Earth. This will require a future mission to retrieve the samples collected by Perseverance and return them to our planet. Only then will we be able to determine the true origin and significance of these intriguing molecules. Section 6. Past missions, future hopes. The search for life on Mars has been a long and winding road. For decades, scientists have sent missions to the Red Planet, each one building upon the knowledge gained from previous endeavors. The discovery of Cheyava Falls and its intriguing features is the latest chapter in this ongoing saga. Previous missions, such as the Viking landers and the Curiosity rover, have provided valuable insights into Mars's history and potential habitability. The Viking landers, which touched down on Mars in the 1970s, conducted the first experiments designed to search for signs of life. While their results were inconclusive, they paved the way for future missions. The Curiosity rover, which landed on Mars in 2012, has been exploring Jezero Crater, an ancient impact basin that may have once held a lake. Curiosity has found evidence of past liquid water, organic compounds, and other conditions that could have supported life. The discovery of Cheyava Falls by Perseverance builds upon the findings of these past missions. It provides further evidence that Mars was once a much different place than it is today, with conditions that may have been suitable for life. However, to truly answer the question of whether life ever existed on Mars, we need to bring samples back to Earth for detailed analysis. Section 7. The quest for Martian life continues. The discovery of the Cheyava Falls rock sample by NASA's Perseverance Rover is a major milestone. The rock's unique characteristics, including its calcium sulfate veins and organic compounds, offer clues about Mars's past and the possibility of life. However, the quest for Martian life is far from over. The findings have raised more questions than answers. Are the organic compounds remnants of ancient microbes, or were they created by non-biological processes? To answer these questions, scientists will analyze the samples on Earth. Plans are underway for a mission to retrieve these samples. This mission, a joint effort between NASA and ESA, will be complex and challenging. The scientific rewards are immeasurable. The discovery of life beyond Earth would be profound. It would reshape our understanding of our place in the universe. The Cheyava Falls rock sample brings us closer to this answer. The quest for Martian life continues.